U sub day 2, one awful problem. So there's only one, but it's awful. Most of today's assignment is the next worksheet in the packet. It's worksheet 26 because it's borrowed from somewhere else. It's obviously not the 26th worksheet we've done or the 26th U substitution worksheet. It's just pulled from a different stash of worksheets. Anyway, here's our awful problem. The integral of x plus 2 times the square root of x minus 4 dx. And it's awful because it's hard to pick what u is so that du shows up. Actually, that part's not too bad. It's what comes next. Any guesses on what we would pick for u just based on the ones we've done so far? You're probably going to be right in picking u. Good. Why did you pick x minus 4 instead of x plus 2? Because it's under the square root. It's more complicated, and that's usually what we've been doing. So that is correct. So we'll let u be x minus 4. Okay, so that wasn't too bad. So we took care of that. What's du then? 1. And then we moved the dx over. 1 dx. So that's good. Well, kinda. So I've got part of this taken care of. Sort of the 3 pieces, 2 of them I've got handled, but I've still got this x plus 2. And I can't be combining x and u's. Like if I want to use u substitution, I got to go all in on u substitution. I can't integrate where some of it's in x and some of it's in u. Like I gotta pick one and go with it. And so that x plus 2, I need to do something with that. And it's not necessarily what u is. So this is where we're kind of stuck, and this is the awfulness of the problem. It's not that the math is awful. It's just like, well, how did you know to do that? So the plus 2 doesn't so much bother me, but I don't like the x there. So if we rearrange what we already have, if u is x minus 4, then what is x equal to? Get that part, just looking at this. U plus 4. So that means I can take u plus 4 and plug it in for x. So let's see what this does. So the integral of u plus 4 plus 2 times the square root of u du. Well, your initial thought is probably, well, like, okay, so it's all in u, but is that really helpful? Because I've got u plus 6. I'm going to rewrite that as u to the 1/2 du. Any idea on what we would do next? Yeah, I want an antiderivative, but I can't yet because there's not a product rule for antiderivative. So I can't antiderivative this and then antiderivative this and then like put the pieces together. I can't do that. Multiply them together. So let's distribute that u to the 1/2. So u to the 3/2 plus 6u to the 1/2 du. Now I can antiderivative. I can handle each of those. So that's u to the 5/2 times 2/5 plus 6 times u to the 3/2 times 2/3 plus C. So 2/5. Let's see, U was, I got all sorts of stuff up there. U was x minus 4. X minus 4 to the 5/2 plus, let's see, I guess I could leave that, but that's not hard to do. 12 over 3 is 4. X minus 4 to the 3/2 plus C. And if this was a free response question, I would stop there. That would be a nice safe stop. That'd be a good answer. Be okay with that. Are you okay with that? I'm going to do some more with that, but the more I'm going to do with it is algebra. We're done with calculus for this problem. Because on multiple choice tests, in the back of the book, and on Calc Chat, they're going to get creative, maybe, in how they factor this. So let's back up to, it's almost easier to factor when there's u's involved. So I'm going to back up a step. Come back to that one. 2/5 u to the 5/2 plus 4 u to the 3/2 plus c. All right, when you factor out a variable, you factor out as much as you can. All right, so how many u's can I factor out if I'm taking as much as I can? I'll take u to the 3/2 out. So I'm going to factor out a u to the 3/2. And I'm going to factor out, maybe the easier way to say it is you factor out the smallest one. You can also factor out the smallest number. So I'm going to factor out a 2/5 as well. It's going to be real fun because now I got to figure out what goes in there. Plus c goes at the end. That part's the easy part. So the first one I think is easy. 2/5 u to the 3/2 times what would give me 2/5 u to the 5/2? Just u to the first. 3/2 plus 1 would give me 5/2. I'm good with that. Second one, I took the u to the 3/2, so that part's easy. But I got to figure out 2/5 times what gets me 4. 2/5 times what? I don't really want to use an x. Gives me 4. So 4 divided by 2/5, or 4 times 5/2, would be 10. Two-fifths of 10 is 4. It makes sense now, but getting to the 10 is maybe the tricky part. We can't leave u's, so 2/5 x minus 4 to the 3/2 times x minus 4 plus 10 plus c. And then a multiple choice wouldn't leave that. 2/5 x minus 4 to the 3/2 x plus 6 plus c. That would be my multiple choice answer. And again, if you look at your free response answer compared to your multiple choice answer, usually if you make it to free response, like if you're working a problem and you get to a spot where you think I would stop here, then you start looking for the answers. Usually they're close enough that you can kind of do the algebra in your head and figure out which one of the multiple choice answers matches, where you are in the problem. But on this one, if you make it to here and you start looking at your answers, you're probably not going to pick this one to be it, because like x plus 6, where'd that come from? And why is there just an x? Why aren't they to weird powers? Well, it's because we did some weird factoring to make all that happen. So that's a yucky problem. On today's assignment, worksheet 26, There are a couple of them like that, so I'll maybe flag those for you. Let's see. Most of them are straightforward, but 21 and 24. And 23. And 21 to 24. So your assignment is worksheet 26, but 21 to 24 are I don't know how to phrase those type of problems. It's where you have to sort of double back and use that. Once you've set what u is, then you got to tell me what x is, so that you can sort of finish the problem. So it's u substitution, but then it's x substitution to get the rest into u's. So the first 20 on worksheet 26 are pretty similar to the ones that you did from page 301. Very straightforward u substitution problems. Most of them, there's one of them that's nearly identical, but most of them are pretty straightforward in terms of picking u. Then you get to 21, and things get a little bit weird. So you know what? Let's do. So 21 is really similar to the one we just did. Let's do one of the others and see if we can figure out what is going on. Yeah, you already have this worksheet. It's in the packet that you got. So looking at 22, 23, 24. Any preferences? I'm going to say 22 is pretty close to 21. Let's do either 23 or 24. 23 and 24 are really similar, so either one. We'll do 24. So yeah, 21, 22, pretty close to what we did as our one awful problem. 23, 24, similar to each other, not as similar to the one that we did. So let's do 24. I think the good news is you guys are getting pretty good at picking u and du. So that's helpful. Any thoughts on what u should be for this one? 2x minus 1. That'll take care of this denominator down here. Derivative would just be 2 dx. So that's nice. I can handle that. In fact, I don't know if I want to use that 2 to go with the dx or if I just want to put my own 2 on there. I think I just want to put my own 2 on there. And then the half out front. So there's du. Okay, we're getting close. Closer. Kinda, I guess. 2x over u to the 1/2 du. But I can't, right? I mean, it's okay to write that. It's not, I can't really do anything with that because I got x's and u's. So it'd be nice if I could replace 2x with something, especially something that had u in it. What? How about just solve for 2x? This one's kind of... So yeah, x equals u plus 1 over 2, but what does 2x equal? U plus 1. And kind of skip a step there on the not having to deal with the 2's and the 1/2. So 1/2 integral of u plus 1 over u to the 1/2 du. Okay, there is no quotient rule for antiderivatives, so I've got to do algebra next. Right? I can't antiderivative the top and the bottom and then like put them back together. It doesn't work that way. I've got to do algebra first. So u to the first over u to the half would be u to the half. And then 1 over u to the half would be u to the negative 1/2. Okay, well now I'm done with the hard stuff. This should be straightforward from here. Increase the power by 1, divide by the new power. Careful with that 1/2. It's supposed to go to everybody, so I'm going to leave it out front for now. The next one, increase the power by 1, divide by the new power. Don't forget the plus c. Let's see, not quite done because I definitely need the, let's see, what do we want to do with this thing? Let's distribute the 1/2. So 1/3 u to the 3/2 plus u to the 1/2 plus c. I'm going to factor out, because I want to get used to being able to get the right multiple choice answer on the test next week. So I need to work on my algebra. I'm going to factor out the smallest coefficient. That would be 1/3. And the smallest variable, that would be, or the smallest power, that would be u to the 1/2. Now I need to figure out what goes in the blank. So I need 1/3 u to the 1/2 times something to give me 1/3 u to the 3/2. So what needs to go in this first blank? U to the first. Because 1/2 plus 1 will give me 3/2. And the 1/3's taken care of. In the second blank, I got the 1/2 u to the 1/2 out of there, so it just needs to be 1/3 times what would get me to 1? 3. Plus c. Although, if you ignore the plus c and just throw it on in the end, that's fine, but you end up forgetting it if you try that way. So 1/3 u is, look back at the top here, u is 2x minus 1. So 2x minus 1 to the 1/2 times 2x minus 1 plus 3. It is a safe stop, and we could have safe stopped this long ago. The trouble is, on multiple choice test, it's like, do you recognize when they keep going with their algebra? That won't be the multiple choice answer, because there's one more thing I can do.
Square root.
You could distribute. You could put a square root over there. Yeah. I don't think I would actually distribute anything, but I could factor out a 2.
Oh my. No chance they would do that.
The 2 from there. So again, your calculus is done way back there, really. And so most of you, like, you're good test takers, so you get that far and you start looking at your answers and you see that as an answer and you're like, wait a minute, that doesn't look anything like what I've got. So there's more algebra to be done. So they're a headache because the calculus isn't awful. It's a little bit of trickery, but then the algebra is kind of a headache. So I'll stop there. Assignments, worksheet 26. Most of them are straightforward, but those last four have the trick in them.